Download this code from codegive.com, link in the description below. C5w3l05 Error Analysis of Beam Search. Overview of Beam Search. Beam search is a heuristic search algorithm that explores a graph by expanding the most promising nodes in a limited set. It is widely used in natural language processing, NLP, tasks, such as machine translation and text generation. The main idea is to keep track of the top k candidates, the beam width, at each level of the search tree, rather than exploring all possible candidates. This approach allows for a balance between exploration and computational efficiency. C5w3l05 Error Analysis. Error analysis in the context of beam search typically involves evaluating how well the algorithm performs and understanding the types of errors it makes. This can include 1. Identifying common error types, understanding whether errors are due to poor choices in the beam search process or limitations in the underlying model. 2. Beam width sensitivity, analyzing how different beam widths affect performance. 3. Diversity of candidates, assessing how diverse the candidates are that are retained at each beam level. 4. Comparing against other decoding strategies, evaluating the performance of beam search against other decoding methods like greedy search or sampling. Example, error analysis of beam search. Below is an illustrative example of how you can implement beam search and perform error analysis using Python. We'll simulate a simple language model and apply beam search decoding. Step 1. Set up the environment. First, install the necessary libraries, if you haven't already. Step 2. Implement the beam search algorithm. Here's a simple implementation of beam search for generating sequences. Step 3. Conducting error analysis. Now that we have our beam search implemented, we can perform error analysis by evaluating the generated sequences. 1. Define evaluation metrics. Choose metrics such as BLEU score, perplexity, or custom metrics relevant to your application. 2. Analyze generated sequences. Look for patterns in the generated sequences compared to expected results. 3. Visualize results. Use plots or tables to visualize how beam width impacts the quality of generated sequences. Here's an example of a simple error analysis function. Conclusion. In this tutorial, we implemented a basic beam search algorithm and conducted a simple error analysis to evaluate generated sequences. The key points to consider in error analysis include identifying common error types, analyzing the effect of beam width, exploring how model predictions can be improved. This process can be expanded with more sophisticated models and larger data sets for thorough analysis. The understanding gained from error analysis can help refine model training and improve the overall generation quality.